Okay. Hi, everybody. My name is Jason Dooley. I'm from NASA. I'm here to talk to you about some of our work that we've been doing in open innovation. I'm actually situated at Ames Research Center, which is in the Bay Area, California. But I am here this week to see all of you and talk about our work, as well as meet with my counterparts here at headquarters, one of which is right here, Beth Beck. I couldn't do this work without her support. So the Open Innovation team sits in the OCIO office at NASA and in a division called Technology and Innovation. We do a bunch of cool stuff. In addition to addressing OMB mandates, we've actually made mandates fun by taking those mandates and putting cool front ends and trying to deliver additional value through web and IT capabilities to our end users. So some examples of those here. So one of the kind of truly innovative things that our team has done is this Data Knot program. Data Knots is really an activity to get folks more involved with data science and getting to play with NASA technology. So every year there's a new class and we get a new crop of folks who help work with NASA engineers and scientists to solve NASA problems and having fun along the way. This site I'm showing here is open.nasa.gov. This is kind of our open innovation umbrella site. And on this site are links to all the pages that I'm kind of going to be showing. Now, this talk is only 10 minutes long, so I have just a little bit of time. So I thought I would talk about some of the projects and some of the front ends that we have to support those projects. Three in particular. We run some NASA.gov sites, data, code, and API. And I'll show the folks today kind of what that is and how we're using that to do outreach and engage with our citizens. So we have a site called data.nasa.gov. And this is really part of an Uber catalog, if you will, of data that NASA puts out. So NASA has thousands of subdomains under nasa.gov that contain all sorts of data sets and information. www.nasa.gov, our main CMS portal, has a lot of informational stuff. Then there's domain-specific in earth sciences, planetary sciences, life sciences, and all the various verticals that NASA has. Each produce data sets. And those data sets, although are on the internet and Google does a pretty good job locating them, what we are doing with data.nasa.gov is providing a top-level catalog of websites, of data sets, so folks can find data based on facets. So this site here, in addition to having a data catalog, which I'll show in a minute, also has a dev portal and some other useful information about NASA data and using NASA data to do projects. Let's see, go to the next one. So the data catalog is essentially a full-text search with some select facets. Now, we could have really went to town when we designed this and put lots of facets. As you know, NASA and other federal agencies maintain rich metadata catalogs, one of which is rolled up at catalog.data.gov. So this particular site feeds that overarching government catalog. And so just to kind of make things simple and intuitive, we've kind of put types and categories and tags as our facets that we have here. And just currently, the way our data is written, or our data is loaded, I should say, these are the facets that we have on this website here. So just to kind of give you an idea of how some of these data sets are represented on our data platform, this is the data catalog where you could search. I searched for a landslide data set. One of the more recent data sets that we've been working with our Goddard colleagues to represent on this data platform. So there's a number of different paradigms in which you could interact with data on our data site. One is you could look at a spreadsheet on the web. So this is nothing more than a tabular data set that allows you to look through and see instances of data or instances of landslides, which is a row in this table. You could do a few things with this data, and there's these features here. There's some built-in visualizations. You could export this data set for offline processing. You could actually hook into this data set dynamically via APIs, application programming interfaces, and you can embed the content and put that on your sites, and there's other different features there. So, as I mentioned, you can actually embed the data into your application a couple ways. You could download the entire data set and bundle it with your app, which, as you can imagine, the disadvantage of that would mean the data could become stale. So what most folks do is create a dynamic linkage to that data through this API. So our data sets on this site are represented on the platform and exposed via APIs and accessible via API tokens, referred to here as app tokens. So this particular website will give some information into some of the types that you would expect to find in the return sets, and information on how to actually make the calls to those resources. Then if you're not building applications and you just want to look at it, what this site has is a bunch of canned visualizations, and then you have this ability to load data sets. So you can mix and match these to do different sorts of things. So this particular case, the landslide data set contains physical locations, which can be latitudes and longitudes, and those can be fed onto a map visualization so you could see where landslides are occurring around the world, and interact with that if you'd like. There's also some other capabilities built into the site that allow you to slice and dice the data, similar to like a Google spreadsheet where you could say, analyze this spreadsheet and it gives you a bunch of plots. This is kind of the same idea, and all of these fields are configurable. And again, all the stuff I'm showing, you guys could go and just go to the data.nasa.gov site and play around with these things and try these visualizations and interact with these data sets. So that's the data site, and we could spend a long time talking about some more features, but really, since there's 4.5 minutes, I wanted to jump into two more categories, one being our code. Inside of NASA, we have a long tradition of releasing code back when, the origins of open source. We've recently been working with other federal partners to release the greatest amount of code possible, and we continue to do that. Code.nasa.gov is our website that essentially lists all the code that we have open sourced in one convenient place, with links to the actual repositories where you could go and obtain a copy of that code and get involved with others in the community to hack on that. So there's a simple search interface here. So if you're interested in Java code, you can search for that, find projects on keywords, and view which sorts of licenses those are based on. Also, we have a guide here. This guide is very helpful for folks who, both inside and outside NASA, because we have a lot of partners that we work with in academia on how to go through the code release process. And we have a very extensive process at NASA for intellectual property and legal reasons to transfer technology to and fro. So this, in addition to having a cool rocket ship decomposition, shows you all the different parts and all the different points of contact to understand our process at a very high level. I also do want to mention that NASA has a very large GitHub organization on github.com/NASA. And here you'll see the majority of our code projects, and you can kind of see just kind of how many active users and whatnot are there. And this is kind of a cool visualization I like to show. People often ask me, what languages is NASA developing in? This kind of gives you an idea here, just kind of the market share of different languages. Yeah, we still have some Fortran in there. We have some other unique and boutique languages, but it would be pretty much what you expect from most other dev shops. We have, we're across the board with some higher than others. Okay. So the last topic in our kind of three-headed monster of stuff is our API sites. So having data sets was kind of a first step. The code stuff has always kind of been there. We really would like to get into the mode where we deliver our data sets as dynamic APIs. We don't think citizens should be in the business of having to take up valuable disk space to store data and then be in the business of having to keep that data refreshed with some various dynamic sources. So what we set up was an infrastructure and a catalog, if you will, of data endpoints that are APIs that NASA's put out on the internet. API.nasa.gov, it's actually a website that runs on github.com. So the federal government is trying to leverage vendor tools, and this is one example of a .gov living on being served up out of GitHub pages. This particular site has the ability to interact with our API. So here's an example where you could go and kind of get a feel for how to make a call. There's some JavaScript code here with a simple AJAX call that stuffs a bunch of stuff into a request and then gives you back a response and then puts it all into a web page so you can kind of see how it works. And although all the APIs are slightly different, for the most part, they're purely RESTful and they have a lot in common with how they're structured. On the API page itself, there are just a bunch of APIs here, and we're continuing to add more and more. So if you were interested in, like for our last Space Apps Challenge hackathon NASA did, we had folks building Minecraft worlds with our Vesta, Moon, Mars APIs, and built some really cool stuff. So that's really it. My name's, again, was Jason Dooley from NASA, and if you want to get a hold of us, send an email to that right there, and I'll get back to you. All right, thanks a lot.